Hello, I hope you are doing great. Today we are going to see an example of how to generate the client proxy for an API which has Open Api Specification documentation. So in this case we are going to use an API that I found in the net, and is this one. Is this pet store? You can go to that URL and see the API, right? You see that it has pet, some posts, right, puts, gets, etc. and so on, right? And we have things like this get store inventory. You can go to try, execute it, and you will get this sample, right? Okay. So what I did is I created a class library. It needs to be in .NET standard, right? Because currently source generators are only working on .NET standard, right? So this class library is generated in .NET standard. It needs to be marked with lang version preview, right? And you have to set this copy local files assemblies equal to true. Now you also need to add this include assets all. Well, I'm not sure if you need to add them actually, but I add them there. Okay. Our code is simple. Basically, what we are doing in here is iterating through I'm sorry. We are iterating through the additional files collection that is part of the generator execution context, right? You see that here we have a class that is marked as a generator and implements the iSource generator interface. This method is or belongs to this interface, right? The signature for that method comes from this interface, right? And that's the method that will be executed when we compile the application, right? We verify if that is of additional file, right? Which I don't think we have to do it. I had another type in here before, a custom class I see here, but I don't think we need it. You get the source text, right? And we get the request URL. Then we request or do a query, HTTP call to that query to get the actual JSON document specification, right? Basically, what we are doing is going to the swagger.json, right? Get all of this in memory, and then we are passing it to this method, which is the one that is going to generate the class. So you will see that down here we have this Open API string reader, which is Microsoft package that allows you to parse Open API documents, right, and makes things easier. So we iterate through all of the paths, we get the operation name, right? We build the method name, we get the parameters which are in there. We need to evaluate which type is defined in the schema, and we need to map that to a C# compatible type, right? So for Boolean, we convert it to bool. Array, we convert it to an object array because we do not really know if it's an array of integer, array of strings, or anything else. So I'm not sure. This could probably be improved. I'm not sure. If it's an integer, we map it to int, right? And if there is no other, we set the schema type, assuming that this will be compatible, though it may not happen. So we need to be careful with that one. We build the method parameters string, right? And then we start building the the additional, the HTTP client. We're going to pass it in the methods, right? And then since they are all going to be async and we want to follow best practices, we force it to receive, or we declare it to receive the cancellation token, right? Which is going to be default to the default cancellation token if you don't pass it. Then we start building the body, right? And we build the class, and then we do this context.addSource, and I pass the class name, suffix it with .cs, and send the string of that class, right? And that's pretty much it for it. This one is visiting the syntax trees and is evaluating that we have it was evaluating that if it had a valid string in there to add it, and then later use it, but it was simpler with just having this as additional files. So basically the idea in here was that what we wanted to have is like allow you to write that in your .cs file, right? And it will automatically generate your class for you. But I decided to use the additional files instead, so this is not really being used at the moment. Then in your consumer project, this one is in .NET 5, so you can consume it from .NET 5. Oh, .NET 3.1. I'm sorry. It could be consumed from .NET 5 too. Actually, convert it. Probably need to update some packages in here. Seems I don't. Okay. So in this consumer project, you need to go to the project file, and you also need to set it to lang version preview, right? Then you need to add a reference to the project that you need to edit your file and set this output type equal analyzer and reference output assembly equals false, because the C# source generator projects are not normal references. They are actually analyzers. They analyze your code, create and do whatever you specify them to do, right? Which in this case is generating code. So you need to add those two values in there. One thing that you may also want to do is this: add emit compiler generated files, set it to true, and set the compiler generated files output path, right? This is recommended to, it's actually not recommended to be done, but I do recommend you to use it when you are creating your analyzers, when you are creating your code, because it makes it really or way more easier to to debug, right? So let me see, I am going to compile the application. Now we have this OBJ, so let me delete this folder. Let's compile this again, and you see that I got these generated files, right? And here I have all of the code. It's not well formatted because I didn't format it correctly in my generation of the code, but this is the code, and it's what I have tested is actually working. Okay, so what I was saying is that this is not recommended to add. They recommend you to add it only when you are building your generator, so you can see the output and verify that it actually works. So you can verify that it actually works. But when everything works, it's recommended that you don't have it. One of the reasons is that C# source generators, they do not create physical files. All your code is actually created in memory, as far as I know, right? So you will see that when I actually go to my program.cs, you see that I am using these types, right? And that one is generated from in this namespace pti.autogenerated because I declare it like that. Now you will see certain things like my Visual Studio is not 100% aware that this exists, but it actually allows me to compile the application successfully, right? That's because the generators are still in preview, and there are changes that apparently still need to be done in apparently still need to be performed in Visual Studio for that to be working 100%. So if I go and run this, you will see that it took me to this. Well, I put the breakpoint there. If I go in here, it enters the method, and you see that that file is actually generated, or is like a temporary file that is generated in my local directory, temporary file directory. Now it builds the request URL, executes the HTTP call, returns the data, and now you will see that I get a response in here, and it says available equals 596 because that's what I am printing. I am printing the available value of this object, which is the result of this call converted to this type that I created in here, right? And that's basically it. One of the ways that you can use C# source generators to be able to generate your proxy client for any API. I hope this has been useful. Thank you very much. Remember, share the video, like the video, right? Subscribe, and please ask more friends to subscribe to the channel so I can keep making more videos. Thank you very much, and have a great day.